Hey, we're on. All right. Not sure what happened with the other one. Might have something to do with the fact that I tried to get a preview started downstairs. I had another session going on, and something didn't like what was going on here, so I've had to move it. I need to send out an email quickly to my other class as well. So let me get that done. And welcome, everyone. Here we have a viewer. Excellent. So some of you were able to find me. I'll give it just a few minutes to let everyone find their way to today's class. We don't have all that much to cover, I guess, just one fairly short activity. And let's just do the first 2 pages of activity number 18. There's a problem at the end of that one, end of 18. It's something we covered on the last test. In fact, I copied and pasted pretty much that exact problem and used it on activity 17. So that's one I used last year, but it doesn't seem to be appropriate any longer. So now we're just going to look at the first 2 pages. If you want to go back and explore that, that's a really nice one for max and min type problems, but you don't have to do that. So activity 18, I guess, is the main focus of today's lesson. I did get an email from a student reminding me that there's still one student that wishes to take the exam, and they scheduled for Friday. So it looks like you'll have to wait a little bit longer to see the results from that last one. I did mention this many times between emails and yesterday's session that the results were outstanding on that. So that was really good to see. Any questions at all regarding how everything's going? From my perspective, this has been a really smooth transition. Being a bit of an introvert, someone said this is like introvert heaven, and it's probably not all that far off. I do worry a little bit about others, but I sort of like being home. The coffee's better, the food's better. I got a nice garden in the backyard, so things are going well. Do we have the last page of 18 for credit? No, you don't have to do the last page, just the first 2 pages. Indefinite integrals. Drew, the indefinite integrals are just the same as the antiderivatives. So calculating that out, let's see, find the antiderivative of x squared, or if you look at this, I guess more in math speak, this is an indefinite integral. Now, as we go forward a little bit, we're going to be looking at something like this. And that's coming up in the next couple of lessons. This is known as a definite integral. And this is an indefinite. So that's the difference between those two. So no, on activity 18, just the first 2 pages is all that you have to do. And it looks like getting those turned in is fairly straightforward. Getting them turned in as an assignment on Blackboard looks like it's fairly straightforward. Photo it, send it to your computer, store it someplace on your computer, and then upload it. So that's crew, yeah. Got you, crew. So we started with, I don't remember how many basic antiderivatives. 1, 2, 3, 4, 9. And then one word problem for number 3 that sort of puts together a couple of disparate ideas. Okay. Yeah, I kind of remember that one too. There was one, and I know the type. It was something like this. And we've worked with problems where we're dividing by a monomial. We worked on those quite a bit in when we were taking derivatives, and it turned out it was a whole lot easier when taking the derivatives to actually divide that into each of the pieces first, and then take the derivative later. And that's going to be the same thing here. So we're dividing here by a monomial. There's just a single term. So since we're we're presented with that problem, let's actually do the division first. So before we go into the antiderivatives, and since we've cut the curriculum just a little bit for this semester due to the shifting everything offline, or shifting everything online, we're not going to cover the integration by substitution. So that's going to really limit the type of antiderivatives we're going to be able to do. So we'll be able to use just these rules: the plus minus rule, constant multiply rule, the power rule, what to do if you have 1 over x, and then the antiderivative of e to the x. So moving on then, let's wrap this one up. We can do this one, do some algebra here, cancel out the x squareds. We're left with 8x squared. The next one becomes what? Just a 7x. And the last one is 2 over x dx. So notice I've done just algebra so far. I haven't applied any of the antiderivative rules, just algebra to go from this down to that. So now let's see if we can work the rest of the way through. I did a little bit on my review yesterday. I took one more step here. If there's a constant, I tried to bring it out front. So maybe this one I could rewrite as 8 antiderivatives of x squared dx plus 7 antiderivatives of x dx minus 2 antiderivatives of 1 over x dx. Get the constant out of the way. And again, I don't really care if you do or if you don't, but some people find it helpful. Now I'm ready for the power rule for an antiderivative, which is sort of the inverse of what we did before. Keep the x, raise the power by 1, multiply by the reciprocal of the new power. There's the first term. Keep that plus sign, keep the constant multiplier. Same thing here. Keep the x, raise the power by 1, multiply by the reciprocal of that new power, minus 2. And here's the only problem where the power rule doesn't work. Remember, this could have been written as x to the minus 1. Raising the power by 1 and dividing by the new power involves dividing by 0. So that's when you see that dividing by 0, you should put the brakes on and think, oh, wait a minute, that can't work. So now we have to just think of this in terms of, well, what function has a derivative of 1/x, and that's natural log. We need the absolute values presented there because the domain of this is all real numbers except 0. We have to make those two domains line up, plus c at the end. Okay. Yeah, this was on the MyLab's homework, wasn't it? Yeah. Again, but we've seen so many of those cases where we divided by a monomial. We did a bunch of those in derivatives. I was hoping you'd remember on the MyLab's how to do that without. Number 3 in activity 18, sure, Anthony. That's probably the one that's makes you really think a little bit as to the relationship between the marginal cost and the cost function. So we're given the marginal cost function. Let me write that marginal cost function up there. And remember that marginal cost is the derivative of the cost function. So thinking back to marginal analysis, I think that was the first stuff we talked about on exam 2. So we know that c prime of x, the derivative of the cost function, how the cost is changing, that's equal to 12,500 x to the negative 0.85. X is the number of carriages produced each month. Suppose also that has a fixed cost of, okay. Since it has a fixed cost, that means if I am producing 0 of these things, I'm still going to have costs of 54,300. That's the information that I'm giving at the very start of the problem. Now we need to come up with the cost function. Well, if I'm going to come up with a cost function here, what I know is the derivative of the cost function. So coming up with a cost function, I'll have to go back and use the antiderivative. So I'm going to take the antiderivative of I could, if I wanted, bring the 12,500 out front. I don't really care if you do or if you don't, but that's a nice way to remember that it's a constant multiplier. Constant multipliers get brought right along. Keep the x, raise the power by 1, and multiply by the reciprocal of that new power. And one more time, I didn't bring a calculator with me. Now I'm going to I could put a plus c back here, but since we're using c, I'm going to use a different letter. I'm going to use k for my constant. So here's my cost function, c of x. Someone with a calculator do that 12,500 divided by 0.15. That'll make it quite a bit bigger. So what do we get for this number? Thank you. 83,333. So now we're able to, in this case, we're able to figure out what this k is. Remember, the derivative of this will get us right back to our marginal cost. The derivative of this is that. But there's this little bit of information that we'll be able to fill in as well. we know that when we're producing 0, that the total costs are going to be 54,000. So I'm going to use this second bit of information, C of 0, when I plug in 0 into this equation. That has to be 54,300. With that information, I can now go back and figure out K. Well, 0 to any power is equal to 0, so that one disappears. I know then that K is equal to 54,300. So here's my cost function. $83,333 x to the 0.15 plus 54,300. Get this, the two things that I need it to do. Remember, the derivative of the cost function was marginal cost. If I take the derivative of this, I get that. And also, when I plug in x equals 0, I'm back to the 54,300. So this is what's known as an initial condition. Initial because that's what happens at the very beginning before anything else has happened when the variable is equal to 0. That initial condition allows us to write out what that constant is. And it doesn't necessarily have to be an initial condition either. I could have said that the cost of manufacturing 8 of these is 60,000. We still could have figured out what that C at the end of the problem was. So a little bit of information going on that one from before. Now we're working backwards. Now we know how quickly the costs were changing. We'll see if we can come up with what the cost function is. Oh, by the way, we will. I'll start back on the quizzes. Quizzes will be starting at the end of class on Thursday. They will always be on Blackboard. Now that I've figured out how to write questions on Blackboard, I'm going to continue doing that. And from this point forward, I'll designate the last 10 minutes of the class for Blackboard for a quiz. See, we officially end at 3:30. So at 3:20 on Thursday, there will be a quiz, and the quiz will be something like one of the first several problems we had on today's activity. I'll give you some sort of a basic antiderivative to find, and you'll find that one. Okay. It could look something like that. I'll probably put 3 terms in it just to make sure that I've covered at least the exponential and then maybe a power rule or two. Gosh, now I'm considering it. Let's see, maybe I would rewrite this one. If I write a quiz like that for Thursday, it really checks everything that we needed to know about antiderivatives. Gives us back to the logarithm, does an exponential, and this one uses the power rule. So this would be an equation like, or an antiderivative like this would be a really nice question to give on the quiz on Thursday. I know I have a couple of students who work during our class times, and we can certainly make arrangements to get that to open up at a little later time if that needs to happen. Not to mention we have some students in one of the 2 classes that are 12 hours removed from us, so Makes a difference. So any more questions either regarding this stuff or anything else that's happened in the course so far? I guess I didn't do part B or part C, did I? All right, let's go back and get part B. So we had the cost function. C of x was 83, 333, x to the 0.15 plus 54.5. Calculate C, what is the total cost at 300? Plug 300 in there, figure out what it is. And I think these were given in dollars, were they not? Yeah, it's straightforward dollars. There's no thousands of dollars. Yep. How quickly is the cost increasing if 300 carriages are made each month? Well, how quickly things are increasing, that's the derivative of the cost function. So it calculates C prime of 300 for that one. The original function that was given in here, the marginal cost function, 12,500 times 300 to the negative 0.85. That certainly should be a positive number. The cost should be increasing. Units on this one, this is the cost. That better be in dollars. The derivative of the cost function should be the change in input over the change in output. This is 300 units of carriages that were manufactured. So this one should have units of dollars per carriage. Quick review on marginal analysis right there. Okay, any other questions? Oh, by the way, I have gotten really adept at using shoot, I lost my pen. I got really good at using Blackboard Collaborate. So if you ever get stuck on, say, the MyLabs questions and want my help, that's a good way to communicate with me. I put the link at the top of the Blackboard page. We can work, small groups on that one or individually. I've been using that a lot with my basic algebra students. They can share their screen with me. There's a whiteboard that I can write on back and forth, and it's I communicate with audio and video. So it seems to be a really nice tool. I'm sure a lot of you are using Collaborate in some of your other classes, but I haven't figured out how to allow you to share your screens and share a whiteboard with me. Does anyone have any questions? Okay, I'm going to step away for just a few minutes. I'll leave this running for just a little while. I'm going to step away and see if I can round up one more marker. And if no one has anything else, say in the next 15 minutes, I'll probably just let this one go, and then we'll fire up again at 3:45 for the other class. Yeah, there will be a video. And go over two. Sure, I'll go over problem two. Will there be a video guide, MLN? Yes. Problem two it is. So in problem two, we're given, again, an antiderivative, and we have to figure out what the function is. So there's two bits of information. So we know the function is the antiderivative of this, so let's get that part done first. And if you wish to do this in two steps, feel free. So the 120 is a constant multiplier. I can break that out front. So that's 120. The antiderivative of e to the x is e to the x. And then again, we have some constant at the end that could be added on. We're given one more time what's known as the initial condition. So when we plug in 0, we must get 25. So let's do that. F of 0 is 25. That's equal to 120 e to the 0 plus c. Now e to the 0 is equal to 1. So 25 is equal to 120 plus c. C is equal to negative 95, I guess. Okay, so now we can write exactly what this function is. it does two things for me. When I take the derivative of it, I get 120 e to the x. That's what the problem said in the beginning. The derivative was that. And also, when I plug in 0, I still get back 25. So both conditions are covered there. So that's problem 2. So if you might have joined me just a little late from the beginning, when you upload these, we're only going to do the first 2 pages. One F it is. So I'm going to do a quick little rewrite of this one. Because I have the power rule for antiderivatives. And really don't have anything else in my toolbox besides constant multiply rule, plus or minus rule. I don't have a quotient rule. In fact, there is not a quotient rule, nor is there a product rule for antiderivatives. So I'm going to rewrite this one. 8, 3, write x, and then get the correct power. Well, it's in the denominator, so I know the power must be negative. And since there's a radical involved, it must be some sort of a fraction as well. Negative 2/3 would be the correct power. So if you wanted to, you could bring this 8/3 up front. And I leave that step totally up to you. As long as you remember to bring that constant multiplier along, you're good. So now let's apply the power rule to this one. 8/3 is the constant multiplier. Leave yourself a little space. Raise the power by 1. Let's see, negative 2/3 plus 3/3 is 1/3. And then multiply by the reciprocal of that new power, 3 over 1. 3's cross cancel. Whoop. Almost forgot. Add plus c at the end. The final form then made look as pretty as possible. 8 cube roots of x plus c. And if you wanted to check your work, and it never hurts to do so, if this was the function you started with and you took the derivative of it, would you get back where you began this problem? Y prime is 8, bring down the power, reduce the power by 1, and add on to that the derivative of a constant, and the derivative of a constant is 0. So is that identical to what we started with here? Oops, with a little work, certainly it is. There's 1F. As you work through these, if you do have more questions, I'm back on at 3:45. Feel free to jump in early there. I had trouble with problem 1G or 1H or whatever. But for right now, since we're down to just a couple viewers, I'm going to close this down for now. We will have a review session tomorrow as well. And I'm thinking probably 3 o'clock. That seems to work a little better than the noon time did. So we could have, if you have any questions that are unresolved today, let's meet again online tomorrow at 3 if you can't make the 3:45 today, if you still have some more questions. All right, but I'm signing off for now, and we'll be in touch